Well, if e to the x is its own derivative, it should only make sense that it's also its own antiderivative, or its own integral. So we're going to use that fact to work out some of these other problems at the back end of section 5.4, like number 9 here. At first I wanted to do a u sub, but I realized quickly that the e's have different exponents on them, so I can't make one of them u and have the other be du. Man, that's a problem. And so after looking at it for a few moments, I realized that the only way to get this right would be to split the problem into two separate integrals. This first integral, underlined in red, comes from this. It's 8 over e to the x, which of course could be written as 8e to the negative x dx. And this green integral comes from this. E to the 5x divided by e to the x. Remember, when you divide powers, you have to subtract the exponents. So 5x minus 1x is the 4x. All right, now we can do each one of those separately. And each one has a u sub that has to be done. All right, there are my u subs I'm going to use. Some teachers will get on me about using u both times. They're like, you need to use a different letter on the green one. Kids will get confused. I'm like, well, I think we're good. All right. If you start with the red, you're going to have an 8 being kicked out front. And then it's simply e to the u, but the du has to be a negative 1 dx. I'll give myself a negative 1. I'll put a negative out front that'll get put onto the 8. And then this negative 1 dx becomes the du. So that looks pretty good. All right, we'll bring the plus sign down in the middle. Now for the green integral, this e to the 4x will become e to the u. But the du is 4 dx, so I need a 4, 1/4 out front. And now this 4 dx becomes the other du. See, I can call them both u. I think you guys are wise enough to know. All right, let's solve. In each case, the integral of e to the u is, well, it's itself. We've already done the u subs, which are backwards chain rules, so we don't have to worry about that stuff. We just have to write an answer. So it's going to be negative 8, e to the negative x, because the red u is the negative x, plus 1/4 e to the other u is 4x, plus c. And that's the answer to number 9. This number 10 has the look of just a classic u sub problem. So let's try it out. I'll start with the u being the most hideous, ugly, heinous part of the problem, which has got to be the stuff inside the 4th root. Ugh. So it's going to be e to the x plus 3. I said that backwards. That's the same thing. What's the derivative of that? Well, the derivative of 3 is 0. The derivative of e to the x is itself dx. So I need an e to the x dx. I certainly have what I need right here. So that's a du. The 10's going to get kicked out. And the rest of this problem is just going to be u to the 1/4 power. All right, let's integrate this. Up by a power, so it'd be u to the 5/4. Divide by the new power, which is like multiplying by 4/5. Remember, there's still a 10 in front. The 10 and the 5 will cancel into a 2 and a 1. So your answer is going to be 8 u to the 5/4 plus c. Just don't forget to put the u back in, and you're all set. I haven't done this in a while, but remember, in Chapter 4, we could check all of our answers whenever we integrate. Well, we integrated now. Let's check this to make sure that it's right. It's an easy check. We'll start with the power rule. 5/4 times 8. 5/4 times 8 would be 40/4, which is 10. Which is good because the problem started with a 10. Stuff to the go down by a power, that's going to be to the 1/4, which is a 4th root, which is cool. That's what we had. and the stuff inside matches the stuff that used to be inside. And then times the chain rule. Does this have a derivative? Yeah, it does. It's e to the x. And you can see that, yeah, that's a correct answer. We have everything that we need. So super easy to check. All right, one more to go. Let's do it. Another u sub, but this time we have a definite integral. So we're going to definitely get just a number or a numeric answer. So we want to evaluate it. All right, well, let's start out the normal way with a u sub. And the best u is going to be this denominator right here, 4 minus 3e to the x. Making du just negative 3e to the x dx. I suppose I could just save a step and just multiply by a half and put a 2 up front. That way you can see that up top here in red I actually have negative 3e to the x dx. So that's du. Of course, that leaves me with 1 over u. There's a 2 in front. Again, notice I'm not putting the limits of integration on. That 0 and that natural log of 3 are both, those are both x limits. I'm in u's right now, so I have to be careful. All right, let's actually integrate it. The 2 comes down. The integral, by now hopefully you know this, of 1 over u du is going to be natural log of u. Natural log of u. U is the 4 minus 3e to the x. All right, that looks good. And now let's evaluate it from 0 to natural log of 3. I'm going to leave the 2 out front. Okay, there's the 2. Okay, in goes the upper limit first. Natural log of 3. E to the ln 3 is just 3. Because remember, e and natural log are inverses. So you have 4 minus 3 times 3. 4 minus 9 is negative 5. Oh man, you can't take the natural log of a negative. Thank goodness for the absolute value. So I'll just turn into natural log of 5. You can see why we need the absolute value now. That's really all it does, is just sort of keeps us safe. All right, in goes the 0 this time. E to the 0, like anything else, is going to be 1. So you have the natural log of 4 minus 3. That's the natural log of 1. Of course, the natural log of 1 is 0. And so your answer is going to be 2 ln 5. Oh, yeah. All right, number 12. We want an equation of a tan line. So right away I'm thinking, hey, let's find a derivative and we'll put it in point slope form. So let's get y prime. The 5 simply drops down. It's e, so the derivative of e to something is just going to be itself. But there is a chain rule in the exponent, so times its derivative, which will be negative 2 plus 2x. X happens to be 2, and we plug the 2 in, some real nice things occur. We have 5e to the 0, because that's negative 4 plus 4. So that ends up just being 5. And when we plug the 2 in here, we get negative 2 plus 4. That'll be 2. So again, this is 1. So we have 5 times 1 times 2. That's going to be 10. So we have the slope. We have a point. We've got our answer. The slope will go in the middle right here. So the 10 drops in. And it's going to be x minus 2 at the end, y minus 5. And there you go. That's number 12. Piece of cake. On we go. All right, this time, number 13, we want the extrema, so maxes and mins, and points of inflection, and then we'll confirm it by graphing. Oh boy, okay, this is a product rule, as you can see. The 4x will be the u, the e to the negative x will be the v, or whatever you like to call those variables. So first off is the first derivative. U prime v will be 4 e to the negative x plus u v prime, which will be negative e to the negative x off of a chain rule. And if we fix that up a little bit, We can factor out an e to the negative x. We can also factor out a 4. So let's take out a 4 e to the negative x, leaving us with 1 minus x. Okay, so that's the first derivative in blue. And now we're going to go for the second derivative. We'll do that in green. And again, we have two things multiplied together, so we're going to use product rule again. No problem. U prime v, this time u prime will be negative 4 e to the negative x. U prime v just stays itself, plus u, which is 4 e to the negative x, v prime, which is simply negative 1. And if I sort of fix that up a little bit, again, I can factor some things out. Let's take out a negative 4 this time, negative 4 e to the negative x. That's going to leave us with 1 minus x plus 1, because this whole thing is factored out, but we took out a negative. All right, so the second derivative is going to be negative 4 e to the negative x times quantity 2 minus x. Okay, so there are the first two derivatives. There's the second derivative. Here is the first derivative. And we have to find the extreme values and the points of inflection. So we'll set each one of those equal to 0. Starting with the first derivative, this in front, this 4e to the negative x, can never be 0. The reason why is because actually it's 4 over e to the x, and that's going to be positive its entire life. So the only thing we can get a critical number off of is this 1 minus x, and it'll be x equals 1. So that's a potential either max or min. We'll try it out with a sign chart. Here's the 1. If you try a number less than 1, let's say you try, 0, you can see that the parentheses will be positive. 1 minus 0 is a positive number. 1 minus negative 1 is 2. Of course, this in front will be positive all the time. Positive times positive, that's going to rise. If you try a number greater than 1, say like a 2 or a 3, 1 minus 2, 1 minus 3, that's going to make this second parentheses negative. It's going to fall. And so, yes, there is a max at x equals 1. We want the extrema. The extreme value is actually the y-coordinate. So we're going to say 1 comma, and we have to put the 1 back into the original up here. It's 4 times 1 times e to the negative first, which is 1 over e. That's simply going to be 4 over e. So 1 comma 4 over e is a relative maximum. And that's the only thing we need to look for. Down here in the second derivative, again, this is going to be negative all the time, because that's negative 4 over e to the x. E to the x has to stay positive. So that's negative. So the only place that the second derivative can be 0 would be at 2. So x equals 2 seems to be a potential point of inflection. Let's see if it is. There's 2 right here. If you try a number less than 2, let's say you try a 1 or a 0. 2 minus 1, that's positive, but then you have a negative in front. So that's going to be, negative times positive is negative. That'll be concave down. If you try a number like 3, 4, 5, let's try 5. Then both of these are negative. The negative times negative is positive. So sure enough, there is a point of inflection at 2. So 2 comma. And it says points of inflection, not x-coordinates of inflection. So we do want the y-coordinate. We do have to put a 2 in here. 4 times 2, that's going to be 8 e to the negative second. That's the same thing as 8 over e squared. And that is a point of inflection. I'd like you to confirm this by graphing. So we'll type in the 4x e to the negative x. All right, let's hit zoom standard, see what it looks like. Yeah, okay. 1 comma 4 over e is going to be the max. Let's just do that. Value 1. 1.4715. I wonder if that really is 4 over e. 4 over e, 1.47. Sure is. Okay, great. So that is the max, 1 comma 4 over e. And then the point of inflection should be at 2 comma 8 over e squared. That's going to be right about there. And you can see that that does look good because we're going from concave down to a concave up look at 2. So that's 2 comma 8 over e squared. Let's make sure that the y coordinate's correct. Second calc value 2, 1.08268. 1.088 divided by e squared. Sure enough. All right. Fabulous. That's 13. One more to go, and we'll be done with section 5D. Number 14, last but not least. We want to find the area of the region bounded by the following equations. I noticed that the two axes are there. X equals 0 and y equals 0, or the x and y axis. X equals 2 is a vertical line, and you've got some crazy looking graph. I went ahead and made a picture of that, and here's what it looks like. We want to find that yellow area. And to me, that yellow area looks like maybe it's, I don't know, between 2 and 3 blocks. It's definitely not 4 blocks, because that would be the full square at 2 by 2, and that's not as much yellow. But it looks like it's more than 2. I don't know. We'll have to figure it out. All right, so again, finding the area, we have to integrate. And this won't be hard as far as the limits. We're going to go from 0 to 2. That's easy. All right, let's see. And we have 2x times e to the negative 1/4 x squared, I'm going to call this, dx. And this is screaming out for a u sub. Let's go ahead and make a u sub. I think the obvious choice for u is going to be that exponent, so the u will be negative 1/4 x squared. I like the fact that it has the squared in it because du then will be negative 2/4 or negative 1/2 x to the first dx. All right, let's do this. We have the dx and the x. Okay, so that's all set. We need a negative 1/2. I'm going to do that. I'll have to put a negative 2 out front. The things I have circled become the du. Negative 1/2 x dx. It says so right here. So those three things become the blue du. There's a negative 2 already out front. This red 2 is going to get kicked out to join it. So that will be a negative 4. And inside, all that we have left is just e to the u, which is kind of what I was hoping for. The integral of e to the u is itself. There's no chain rule, there's no u sub, there's no nothing. So it's just simply negative 4 e to the u. But wait, what's u again? U is negative 1/4 x squared. Okay, we want to find that area. We want to find the area from 0 to 2. I decided to keep the negative 4 out of things for now. That'll just be easier for me personally. In goes the 2 first. That's going to be e to the negative first. Or 1 over e if you prefer. Minus, because that's what we do. First fundamental theorem. Put the 0 in. It'll be e to the 0, which of course is just 1. And if we go ahead and do some distributive property, I'm going to lead off with the positive term. So, we have a positive 4 minus 4 over e. That is the exact area of that shape. Right there. 4 minus 4 over e. If you type that into a calculator, it's approximately 2.528. And you may remember I said it's definitely smaller than 4, but it looks like it's larger than 2. And yeah, 2.528 is the answer. And that's it for number 14. And we're done with 2 days of derivatives and integrals of exponentials.